You'll recall, way back when we talked about congruent triangles, we defined what congruent triangles are, same shape, same size, and then we said in order for two triangles to be congruent, they have to have all three pairs of angles congruent and all three pairs of sides are congruent. And we found that that became a royal pain in the butt to do that. You had to find 6 chunks of information, and we said that's ridiculous. Let's come up with some shortcuts. So we had a whole bunch of shortcuts. What were they?
Angle, side, angle.
Beautiful, that's one of them.
Side, side, side.
Side, side, side.
Angle, angle.
Side,
Angle, angle, angle. Just kidding, no.
You just tested
Side,
it.
side, angle.
No.
Angle, okay.
Side, side, angle is just angle, side, side for wusses.
Side, side, side. Side.
Wait, hold on, let's start over. Because I lost track in all that confusion. Side, side, side.
Side, side, side.
Uh-huh.
Side, angle, side.
Side, angle, side.
Angle, side, angle.
Angle, side, angle.
Angle, side. Oh! H up.
Also known as hypotenuse leg, and you missed one.
Right angle. Angle, angle, side.
Good, angle, angle, side.
Okay.
Okay? And that made our life a lot easier because we didn't have to show all 6 parts. We just had to show 3, sometimes 2, and we could get that the triangles are congruent. Same thing happens with similarity. Up until this point, we know that if 2 triangles are similar, we have to show that all 3 pairs of angles are congruent, and then we need this big, long, honking proportionality statement for the sides. And so today we're going to get 3 shortcuts. And the difference between the congruency shortcuts and the similarity shortcuts is pretty big. So let's start with the problem. You'll need your calculators, by the way, if you don't already have them out. We want to find the height of the flagpole. This flagpole. Okay? There's you. You've got your wagon full of math books, and you're out for a stroll. You are 5 foot 6 inches tall. By the way, I shouldn't have to say this, but I will just so no one screws up. Remember, 5 foot 6 inches is not 5.6 feet tall. But you all knew that, right? Good. And your shadow is 6 foot 6 inches long. All of that can be easily measured. So now you got this flagpole. Excuse the clip art, I just had to find something quickly, so I found this one with a guy running up a flagpole. You obviously can't run up the flagpole to measure the height of it, but what you can easily measure is the length of the shadow, and the shadow of that flagpole is 125 feet long. We're eventually going to solve for the height of the flagpole using our vast stores of geometric knowledge, but let's talk about a couple things that we know in the problem. What kind of things are you going to assume about this problem? Go.
The sun is hitting both you and the flagpole at the same degree.
Good. I mean, you're not in Beijing and the flagpole is in Memphis. Okay. You're right next to the flagpole at the same time of day. That's important. It'll come up later. What else are we assuming? It's okay if it's nothing else. We'll just go from there. All right, good. Calculate. Well, yes, Tom?
That they're proportional, the shadows.
That is a pretty big assumption, yes. Okay, calculate how tall the flagpole is. By the way, will the answer of the height of the flagpole be more or less than 125 feet?
Less.
Why?
Because
Paige, say it louder. Yeah, shadows, you are shorter than your shadow, or your shadow is longer than you, so therefore, the flagpole has to be shorter than its own shadow. fun. What did that say? 8,250? Oh, you didn't say no. Olga, what do you got? Okay, go ahead, we'll wait. What did you have for next? Did you get it yet? Anticipation's killing me.
I don't think I did it right.
Did you get 4 miles?
No.
Good, because that would be doing it wrong. Did you get 6 inches?
No, I got a weird number. I don't.
What, how would you define a weird number? Infinity?
I got
Pi?
I got like
Square root of 3?
0.29 something.
So you got like that tall?
Yeah, I don't.
Or that tall if it's in inches. Is it in inches or feet?
I don't know what I did.
Okay, probably did something wrong. Jess, what'd you get?
105 feet and then 9 inches.
So you converted back, oh, nice, okay. Anybody else, 105? Okay, seems to be pretty good. 105.7776, whatever that is?
Yeah.
Okay, how'd you do it, Jess?
Well, so I converted the shadow and the height of the person into inches.
Okay.
And did the same thing for the shadow of the pole.
All right, so you are how many inches tall?
66
Uh-huh.
over 78. And then set the 1,500 on the bottom, the denominator. And
That's the height of the flagpole in inches.
And then put X on top and then cross it. X equals 1,269.
Point something or another?
Yeah.
Point blah, blah, blah. And that's in inches. No, is inches and is feet?
And then in
Yeah.
feet, it's 105 and then 9 inches.
So you converted the point whatever to inches. We
Oh,
could,
75.
yeah, okay, 75, 7, what, I don't know what the, whatever. 75 feet. Okay, good. Anybody set it up differently?
So instead of 1,500, I just put 125.
You left it in feet?
Yeah. And I got.
But this is in inches.
I know, but I got 105 as my X.
Yeah, I did it.
Yeah, that's.
Wait, yeah, I did that.
Wait, so you have inches on this side, you have feet on this side,
Yeah, that's over.
and you got the right answer.
First time
Yeah.
too.
That's why I didn't.
Oh, no.
Do you want me to show you?
It worked.
No, I trust you.
Oh.
You have an honest face. I'm not calling you out on it.
Okay.
How does that work?
I got the same.
It's
thing.
still be
Instead
proportional.
of
I just-
0.75, we got 0.77.
Okay, split hairs. Yeah. Why does that work? Shouldn't they all be in inches? Anybody, did anybody leave this in feet, by the way? Did anybody do 5.5 over 6.5 equals x over 125? You got the same answer too.
Yeah, then I converted it back into inches.
Okay. Just no reason?
I don't know.
Just want to give your answer in inches?
Yeah.
It's fine. Well, how can different units give us the same answer?
Because 5.5 over 6.5 is the same as 66 inches over 70.
Nice.
And it's just multiplying.
Nice. We're setting up ratios here. And so when we set up a ratio of inches to inches, what happens to the units? They cancel, and we just start working with numbers. This is inches to inches. So when you solve this, our value of x is going to be in inches, and then she converted from inches back to feet. If you write it the other way, 5.5 over 6.5 equals x over $1.25. Feet over feet, well that cancels. Now we're just looking at a ratio with no units attached to it. feet over feet, and we get feet as answers. Units are not important as long as you're consistent. What I can't do is say 5.5 over 78 is equal to x over $1.25. That's not going to work, because this now is feet over inches, and that's not going to work for us. So as long as you have a similar comparison of units, you'd be good to go. Well, that's a mess up there. Is there any other ways you could set that up? Silly question. What are the other ways you could set that up? So we did height over shadow equals height over shadow. What else could I do? Shadow over height equals shadow over height. What else?
Shadow over shadow.
Good. Shadow over shadow equals height over height. They'll all work out the same. Okay? Beautiful.
What
Questions?
was the shortcut that this represented? Because you said,
I'm not there yet.
oh, okay.
Bell.
Wait, so can you mix up the units, like, as long as it's on the same one? Like, I did 66 over 78 equals x over, like, 125. So I did, like, inches.
Yeah, because you got you've got inches on the left side, feet on the right.
Oh, okay.
You could also do inches on the top and feet on the bottom if you wanted to get crazy.
Okay.
But yeah, because again, the units cancel and we're just left with a ratio then. Okay? Good. Now, this whole problem is based on a couple assumptions. One of the assumptions that Sarah already mentioned is that the sun's in the same location. What does that do for us graphically or geometrically, Sarah? If the sun is in the same location, so what?
You can draw a conclusion. I don't know.
It's gonna be like the same slope of like the from the top of like your height or the flagpole to where your shadow, like the top of your shadow, like that diagonal line,
What's that diagonal line called?
the hypotenuse,
Hold on. Hypotenuse. In order to have a hypotenuse, what else do I have to have?
right angle.
Right angle. So, did you all assume that this flagpole is perpendicular to the ground? Well, first of all, what else did we assume about the ground? It's flat. Okay, later on, when we get into trig, we'll start doing problems where the ground isn't flat. For now, it's flat. Did you also assume that you are standing perpendicular to the ground? Yes, because if you had one leg shorter than the other, your name would be
Crooked? Limpy?
Eileen?
Thank you, Eileen. Come on, that's pretty good. One leg shorter than the other, your name would be Eileen. Did someone say I don't get it?
I get it now.
You get it now? Okay. Or did you just say that so we leave you alone?
No, I get. You have to say it slower, and then I just.
I said it to her slower, so she got it.
I understand. Just slow it down. Give you time to process. That angle would be equal to that angle because the sun's up in the same location, and therefore it strikes the flagpole and the top of your head at the same angle. And by the third angle theorem then, we have that angle equal to that angle. Which is great, but that's only half of what we need to show to have similar triangles. The other stuff we need is that the sides are proportional. But of course we can't show that the sides are proportional because we would have to know the information that we're solving for. So this allows us to use the shortcut. And the first shortcut we have is what's called, hold on, I'm getting there. Okay, good. Angle-angle similarity. Used to be called angle-angle-angle similarity until somebody realized, hey, we don't need all three A's. We just need two of them, because if two of the angles are congruent, the third pair must also be congruent. Okay, there's the angle-angle similarity. That tilde that follows the angles is very important, because if you'll recall when we talked about congruency, there is no such thing as an angle-angle-angle theorem for congruency. There is, however, one for similarity. There is still never going to be an angle side-side theorem. That never works. So don't use it. Okay, so let me stress again, you need the tilde there because that establishes it as a similarity theorem and not a congruency theorem. Angle-angle doesn't work. Angle-angle similarity works just fine. So now, like it says, all you gotta do is show that there's two pairs of congruent angles and we're good to go. Those triangles are similar and therefore we can set up a whole bunch of proportions, we can solve for other angles, we can do all kinds of fun stuff. There's two others. Want to guess what they are? Katie, what's next? Go out on a limb. Side angle, side. Tilde, good. Whoops, went out of order, sorry. Here, I'll show you, just so you feel better. We'll get to that eventually. Okay. Side, 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 similarity. All three pairs of sides are proportional, then the triangles are similar. Not congruent, similar. 6 is to 2, as 7.5 is to 2.5, as 12 is to 4. They all equal 3, we're good to go. Don't even have to talk about the angles, just talk about the three pairs of sides. Life is good. And as Katie mentioned, the last one, side angle, side similarity. What's it gonna be? I think, is it? Oh, that's good. Don't write out proportional, use the fishy. Save yourself some time. Now we good? Just like when we talked about side angle side congruency, the angle has to be included between the sides. Show that the pair of angles are congruent, show that the sides are proportional. 12 is to 4 as 9 is to 3. Creeper, you okay?
Yep.
Good. I'm gonna leave the banana there and see what happens first hour tomorrow. Somebody sits there, we'll see if they actually move it or just sit somewhere else.
Where's the banana?
It's the big yellow thing in the back now. You didn't know, you didn't see me put it over there.
Looks like a banana.
Looks like a what?
A banana pepper. Not a banana.
I don't know what a banana pepper is.
Google it. It's like thing they put on your sandwich. Normally they're pickled at Subway. Tastes good. That's what they look
How
like.
spicy are they?
They're not spicy. They're just pickled. Just like vinegar.
It's a pickled pepper.
Eat a pepper.
I was hoping you'd pick up on that.
They look exactly like that though.
With the hair and everything?
Sometimes.
Really?
Let them sit for too long.
Here's a rule of thumb, if your pickled pepper has hair on it, you probably don't want to eat it. Or if it has eyeballs for that matter.
Nobody's eating that thing.
Which is good. Okay. Brian, how many triangles in that picture?
2, 3. No, 2.
2, 3. 2, 2,
Yeah.
2,
2.
2,
2.
2.
2.
Why did you say 3?
Well, I don't know. I just think it
Had
was
a
like
brain
some
fart
sort
there
of
for a second?
illusion, yeah.
Okay. So, question is, are those by the way, Ryan, could you name those two triangles, please, just so everybody can see what you're talking about?
MMP and MRS.
Beautiful. Are those triangles similar? There are, yes, Tom,
Oh, can I answer the question?
please.
I say yes, they are similar because of the A tilde theorem. Or tilde.
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 Okay, so what angles are congruent then?
Angle RMS.
RMS.
And NMP, because they're the same angle.
Okay, so we can implement the reflexive property there.
Yes.
This angle is congruent to itself.
Yep.
That's one pair of angles. We need a second pair in order to use angle-angle similarity.
MRS and
MRS,
MNP.
MRS, and MNP are congruent. Why?
Because they're on the same line. Because the two lines are parallel. And
Whoa, 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 whoa. They're what?
they're parallel.
They are?
They look parallel.
Oh, they look parallel.
Are they parallel? Yeah, because. No, they're not parallel because the sides aren't proportional.
So yes or no?
They're not parallel now.
They're not parallel.
Because 12 and 18 isn't proportional to 10 and 15.
Yeah, it is.
No, it's not, because there's 5
The
difference
line,
between
the line
both of
isn't
them.
15 and 18, it's 10 plus 15, and that's 12 plus 18.
Yeah, I know. Oh, well, they're not proportional.
Yeah, I'm doing that right now.
They're proportional.
No, they're
It's 10
Game
over,
on.
10 over 25.
10 over 15 is 2/3.
Yeah.
12 over 18 is 2/3.
No. Is it?
And then
Yes.
10 over,
Hold on.
Oh, I thought
and 10
18
over,
minus 12 was.
Hold on, did you say 10 over 15?
it's
Yeah.
10 over,
15?
it's 10 over 25.
Yeah, no, you can do it that way too.
You can?
Sure.
15 is not a side of a triangle.
Yeah, it is. Oh, no, it's
No,
not.
it's 10 over 25 and then.
Jill,
It'd be 10.
Side angle side.
say again, I'm sorry?
Side angle side.
Oh, please explain. We've got the angle of this potential side angle side similarity theorem.
If you set up a ratio 10 over 15 equals 12 over 18, you get 180 equals 180. Okay? And then,
Hold on a second. You're saying this ratio?
yeah.
No, no.
Why no?
Because 18 isn't the side of the triangle.
But this works.
Yeah.
This is 180 equals 180 proportional.
Yeah.
That's it, you're just going with yeah?
Yeah.
Okay. Sorry, Jill.
It's okay.
He went with yeah. So what are you saying?
It'd be 10 over 25
10 over 25.
is equal to 12 over 30.
Where did the 25 and 30 come from?
10 plus 15 is the measurement of side MR. And 12 plus 18 is the measurement of MS.
We're comparing sides of a triangle here, not just lengths in the picture. So 10 is the distance from the smaller triangle, 25 is the distance from the big triangle, and we're checking to see if that is proportional between 12 and 30. Jill, we're going to come back to what you said in a couple days, because that is a different theorem that we're going to address later. Question?
Yeah, if you cross multiply those two, it equals, it's 300 equals 300. So
Boom,
it's-
proportional.
Yeah.
Therefore, side angle side similarity proves that the triangles are similar. Now that we know the triangles are similar, we can find NP. So go ahead and find NP. Oops. That's what you got.
8.
Anybody else? 8?
Yeah.
How?
So like the ratio
Yes, please.
from like the ratio is 2 to 5.
Let's use the numbers in the picture so no one gets confused.
So the ratio is 10 to 25.
10 to 25.
Is equal to x over 20. Equals multiply that and get 8.
8, we don't know, 8 units. Good. Now, the point being, you have to use the proportions from the triangles, not from these little pieces that fly up all over the place. All right, so once we got this, what do we know about this guy down here?
So quadrilateral.
It's a good start. kind of quadrilateral? Mary? I said again?
Never mind.
I just didn't hear you, that's all.
No, never mind.
What's your name?
Marion.
I'm sorry, what'd you say?
Marion.
That's exactly what just happened. You gave me an answer, I just didn't hear you, that's all. You might be wrong, and if you're wrong, then we'll all point and laugh at you, but you might also be right. I love when we have these talks. Anybody else? Paige?
Trapezoid.
Why?
Um,
You are correct. Is that what you said, by the way?
Sort of.
What do you mean, sort of? Did you say like trapawongalan?
No.
Or a smenkatenzoid?
No.
So then how do you get, never mind. Back to you, Paige. How do I know that NPSR is a trapezoid?
because there's 5. I don't know. Oh, there's 4 angles. I don't know.
I see.
Because all the sides are different. Just a guess.
That won't necessarily make it a trapezoid. But it does mean it can't be a rhombus or a square.
It's got 2 parallel sides.
How do I know
A set of parallel
that
sides.
this is parallel to this now?
They're similar.
What's they?
NP and RS are similar.
Triangles can be similar, not sides. Sure.
Is it because angle R and angle N, or M and P and N R S are congruent, so like.
Hold on.
correspond-
Why are these two angles congruent?
Because we proved that the 2 triangles are similar,
Good.
so
And those are what kind of angles? Other than congruent.
corresponding.
They're corresponding angles, which makes the sides parallel, which makes it a trapezoid. Good. And we know that RN and PS cannot be parallel, because then it wouldn't make a triangle, you'd have a train wreck. Okay, good, that was fun. Questions on this before I erase? Hot diggity. All right, I believe we are done. Whoops. We are done.